Hello out there. Thanks for taking a few minutes to watch this video today on even and odd functions. Before we get started here, there's an opener that I'd like you to pause this video and try. So I want you to graph this piecewise function and then find the values of the two x values below. So please pause the video at this point, and after you finish the opener, unpause to check your answer. Okay, and here is the answer for that opener. Now, if you remember correctly, we did not do part B this year, so we don't have to worry about that right now. If we did do that this year, then basically we would be looking at the domain of f of g of x. There's no restrictions on this. There's no restrictions on either of these, so this domain would be negative infinity to infinity. Okay, again, this video is on even and odd functions. All right, so what is an even and odd function? That's for you to figure out right now. So again, I'm going to ask you to pause this video at this point and try the next 3 slides on your own. So this slide, this next slide here, and this slide, just to take a look at a couple of functions that are. So take a look at these 3 functions, these 3 slides, and answer these questions here and these questions here to the best of your ability. And then once you're done with those, you can come back and we will move on to the next slide. Okay, so after answering all those questions, that brings us here to putting it all together. We're going to answer the same questions you just answered. You can check your answers here. We're going to fill out this table. So even functions is symmetric over the y-axis. xy is on the graph. That means negative xy is also on the graph. And when you evaluate f of negative x, you get the same thing as f of x. For odd functions, they are symmetric over the origin. When you evaluate negative x, you get negative y. And if you put in negative x, you would get the opposite of f of x. So f of x equals the opposite of f of negative x. So that's a lot to take in there. Let's take a look at a couple more graphs here. So graph A would be an odd function. Okay, you can tell because it's symmetric about the origin. So basically the first and the second and fourth quadrants would be the same, and the first and third quadrants would be the same. Okay, symmetric over the origin. The origin is a mirror, basically. Okay? And then graph B is an even function because this line right here is a mirror. The left and right sides could fold on top of each other. Okay, and again, summarizing, f of negative x equals f of x, or negative f of x, negative f of negative x equals f of x will give you odd or even. If neither of these are true, then we say it's neither even nor odd. And honestly, most of the functions in algebra that we use are neither. Now, for this section, obviously, we'll be doing a lot that are even or odd, otherwise it'd be a waste of time. But for the most part, in real algebra, most functions are neither odd nor even. Okay? So let's take a look at this next slide here. And let's graph all of these. If you need a graphing utility to help you, you can do so. But hopefully at this point, we can graph most, if not all of these on our own. All right, so for the example, the first function, it's just y equals x, right? Well, before we do this, I'm going to go ahead and copy this coordinate plane I just made a couple times. So I'll have to do this 8 times. You can do the same. If you want to pause the video to make these 8 axes, you can do so. All right, so let's take a look at our first function. The line y equals x, it's going to look like this. We should know this by now. The line y equals x. Is there symmetry across the y-axis? There is not. Is there symmetry about the origin? There is. So this one is an odd function. Okay, y equals x. Now, if we were to shift that up or down or left or right, then there would not be symmetry about the origin. But since it's just y equals x, that one is symmetric. to the line y equals 5. Y equals 5 would be somewhere up here. Right, it's just a horizontal line. That one is symmetric about the y-axis. So that one we call even. Third one, the quadratic function. So we should know what that looks like by now. Something like that. Also symmetric about the origin. So that one is also even. Fourth one, root x. We know what root x looks like by now. It should look like this. There's no symmetry about the x-axis, sorry, the y-axis. There's definitely no symmetry about the origin. So this one would be neither. Number 5, the graph of absolute value. Definite symmetry across the y-axis there. So that one is even. X cubed looks like this. Symmetry about the origin. So that one is odd. Cube root looks like this. Also symmetry about the origin. So also odd. And the last one, root 1 minus x squared. So you shouldn't know what this one looks like on top of your head. So you can do a couple things. You can either put x's in to get y's back, or we can graph this in our calculators. So if you go to y equals, make sure everything is cleared out, as always. And we're going to graph square root of 1 minus x squared. Let's get a better window of that. So maybe we'll go negative 4 to 4. And negative 2 to 4. Just to get a good window of what this point look like. And there we have it. It's actually supposed to look like a half circle. So it's going to look like that. And that is definitely symmetric across the y-axis. So another even function. Okay, and the last slide here, we're going to talk about algebraically determine if a function is even, odd, or neither. So we're going to evaluate f of negative x and compare it to f of x. So if we're going to go a of negative x, that's negative x to the 7th, which would be same as negative x to the 7th. So your first question you ask yourself, does that equal the original function? If it did, the answer would be even, which it does not. The second question is, does that equal negative the original function, the opposite of the original function? And the answer to that is yes. So this is the same as the opposite of this, which means this is an odd function. If the answer to both even and odd questions are no, then it would be neither. All right, so now to evaluate b of negative x, well, there's nowhere to even put that, so b of negative x must be 5. Since these two are equal, you're done. It's even. You don't have to check if it's odd. It can't necessarily be even and odd. Okay, so we're just going to go even, and then we're done because we know it's even. Number 3, c of negative x is negative x squared. Okay, negative x squared is x squared. And this is the same as the original function. So this one again is even, and we don't have to check odd. D of negative x would be root negative x. Is that the same as the original function? It is not, so it's not even. Okay? But then your question is, does it equal the opposite of the original function? Okay, so is negative root x the same as root negative x? And that answer is also no. So this one is neither. It's not even nor odd. Number 5, e of x, that would be e of negative x. So absolute value of negative x. absolute values always just means to make it positive. So that would be x. And since those two are the same, since these are the same, right, absolute value of x and x, this would be an even function. But we already knew that. We already knew that the absolute value was even, right? So we just double checked that there. Number 6, f of negative x would be negative x cubed, which is negative x cubed. These are not the same, so it's not even. So your second question is, does negative f of x equal that? And it does, because negative f of x is negative x cubed. So those are the same, therefore this one would be odd. And again, we already knew that. We knew that already because we know the parent function, but that's just proving it there. 7's another one that we should already know, but just for fun, we'll double check. So this would be third root of negative x. Okay, the third root of, so basically we can think of this as the third root of negative 1 times x, which is the third root of negative 1 times the third root of x, and the third root of negative 1 is negative 1 times the third root of x. So are these the same? Clearly not. Okay, but is the opposite of g of x equal to this? It sure is. So therefore, this would be an odd function, which again, we already knew. We're just proving it. All right, 8 is not a function that we know off the top of our head, but we already did it in the last slide. But that's okay. Let's take a look. If we put negative x in, we get root 1 minus positive x squared, which is the same. So this one is even. Okay, that'll do it for our look into even and odd and neither functions. Thanks as always for tuning into our video today.